Hello, Year 9. Today we are going to be carrying on looking at the topic of angles, and in particular, we are going to be looking at how we find a missing angle in a triangle. So I hope you've managed to print out one of my sheets for today's lesson. If you haven't, then can you please just copy down everything that will be on my PowerPoint slides. So although we're primarily focusing on finding angles in a triangle today, you will see us using one other angle rule today. And that is a rule to do with opposite angles. So you can see in this diagram below that if I have two lines that are crossing, so I've got this line here and this line here crossing at a point, we have what we call some opposite angles. The two red angles are opposite each other and they are the same size, and the two blue angles are opposite each other and they are the same size. So for example, if S was 120, T would be 120. Yes, these angles will still add up to 360 degrees. Yes, we also have some straight lines going on, but the important thing is the opposite angles are equal. So the angle rule that we're mainly using today is the angles in a triangle, and the angles in a triangle add up to 180 degrees. This should be a rule that is very, very familiar to you. You will have met this in Year 7 and Year 8. So regardless of the triangle, its shape, its size, the angles at the three corners, in this example A, B and C, will always add up to 180 degrees. Now what that means is if we know the size of two of these angles, we can calculate the third one. So we'll start with a couple of easier examples, and then we'll progress on to a slightly more complicated diagram. So, first of all, this first diagram, you can see we've got some opposite angles going on here. We've got two straight lines that are crossing. So immediately we should be able to say what the size of angle B is. B is 113 degrees. And I'm just going to say why. It's because it is an opposite angle. How would I work out angle Y in this triangle? Well, we know that the angles in a triangle add up to 180, and I've already got two of these angles. So what I need to see is what do those angles already add up to, and what would be left for 180. And again, this is where it's going to be dependent on your ability as to whether you are confident at adding numbers together in your head or whether you're going to use a place value method. So I'm just going to quickly add these angles up. I'm just going to do it using a place value method. So I've got 71 and 66. If I add the units, that is 7. If I add the tens, that is 13. So those two angles add up to 137. So how can I work out angle Y? Well, it's what is left from when I've added those angles together and subtracted it from 180. So it's 180 take away 137. And this might be a good way of setting it out, particularly if you weren't doing a written method for your addition. So it's 180 take away 137, and that comes out as 43 degrees. Again, if you need to do a written subtraction for 180 take away 137, then I would recommend you do that. Let's look at some more complicated examples. Ones where we might have to bring in some other angle rules, or perhaps work out some extra angles along the way in order to work out the actual final angle we've been asked to find. So, in this question here, we have a triangle, but we have these extra lines, and these extra lines are forming some opposite angles. So I know that that angle there is actually the same as C. And I can work out this angle here using my angles in a triangle. So I'm going to add together 44 and 58. And these two numbers add to make, well, I'll add the units first. 4 and 8 is 12. 4 and 5 is 9. Add the extra one that I've carried, makes 10. So that's what these two angles add up to. Now let's subtract that from 180 and see what's left. 180 take away 102 sounds like 78 degrees. So angle C is 78. Now, in my final example, my final diagram, I have a triangle, but the base of the triangle has been extended to make a straight line. Okay, so all of those angles there would still add up to 180 degrees because of the straight line. And that's what I'm going to need to do first. I'm going to need to work out this angle here in order to then eventually be able to work out what angle W is. So I'm going to use angles on a straight line, and you could introduce a different letter. I could call this angle Z if I wanted to, and then I'm actually talking about something very, very specific on my diagram if I've labelled it Z. So I'm going to say that Z is 180, take away 105, and that is 75 degrees. And I could say I've used angles on a straight line. And now that I know that that is 75 degrees, I've got two of my angles in my triangle. I can add those together and see what is left to work out W. So I'll do that addition up here. 37 and my 75. If I add that together, 7 and 5 makes 12. 3 and 7 is 10. Add the extra one is 11. So those two angles add to make 112. So to work out W, we are going to do W equals 180 take away 112. And 180 take away 112. Again, if you need to do a written subtraction, I would recommend doing it. I've just done it in my head, and the answer is 68. Now, do make sure you go back and have a further look at my instructions, because the questions that you are going to try today are on the PowerPoint. So follow the link, follow the correct pages, make sure you're drawing out some diagrams, make sure you're showing some working out, and then you can check your answers at the end. If you've got any questions, remember, you can ask in the Ask the Teacher channel.